Parallel and perpendicular lines are today, so let's get started. First thing we're going to talk about is parallel lines, and parallel lines usually have markings on them. If you see in the picture here, there's a marking here and a marking here, and that means that those two lines are parallel to each other. So anytime you see those little triangles on some lines, that means those lines are parallel to each other. And we don't actually write out line R is parallel to line S. Instead, we use this notation right here. And that means line R is parallel to line S. The other type of line that we're going to talk about today are perpendicular lines. And those usually have a little box to indicate that there's a 90-degree angle. So anytime you have two lines that are perpendicular, they form a 90-degree angle. And when you're saying that two lines are perpendicular, like in this picture right here, M is perpendicular to X, you would use this notation right here to note that those two are perpendicular. That notation looks like a kind of an upside down T, if you will, but that means M is perpendicular to X. And don't forget, perpendicular means they form 90 degrees. So let's look at some examples. Determine whether the lines are parallel, perpendicular, or neither. Now, don't push this away. Make sure that you do draw on your picture. So I'm going to draw on the picture and I'm going to erase them when I'm done. They're talking about line N and they're talking about line M. And what are those two lines to each other? Well, they're not perpendicular because they don't cross over each other, right? Matter of fact, I'm going to use a highlighter because I think the highlighter is going to be easier to see. These two lines look like they're what? Parallel, perpendicular, or neither. Well, because they have these little markings on here, they are parallel. So those two lines are parallel. So let's look at the next set of lines. We have line P and we have line Q. So we have line P right here, and then we have line Q right here. Now they're not parallel because they don't have the markings, plus they intersect, right? And parallel lines never, ever, ever intersect. So they can't be parallel. Are they perpendicular? Well, if we look here, I don't see anything saying that these two highlighted lines form a 90-degree angle. So we can't say that they're perpendicular either. So we're going to have to say that these lines are neither parallel or perpendicular. They are neither. They're just plain old intersecting. So let's look at C. We have line N and we have line P. So N and P. Now these two lines do intersect, and if two lines do intersect, then they cannot be parallel. They cannot be parallel. And do they intersect at a 90-degree angle? Well, I see this little box here where these two lines intersect, and that little box means 90 degrees. So yeah, these two lines intersect at a 90-degree angle, so that means those two lines are perpendicular. Remember, if I'm going too fast, you can pause the video, or you can rewind and rewatch. The best thing you can do is watch the video through the first time and then go back and write everything down and watch the video a second time. Okay? So just a little tip there for you. Let's talk about skew lines. Skew lines are lines that are not parallel and they also never intersect. So if you look at this picture of this 3D object here, it's a cube, you'll see that segment AB and CD are never going to intersect. If I extend out this side of the cube forever and I extend out this side of the cube forever, they will never, ever, ever intersect. Plus, look at them. They're definitely not parallel, right? So not parallel and not intersecting at all. So let's look at this example right here. Determine whether the lines are skew. So we've got line F, which is right here, and we have line H, which is right here. And you have to ask yourself this question first. Are the two lines parallel to each other? No, definitely not, right? Do the two lines intersect each other? Well, yeah, it looks like they intersect each other right here. So skew lines are not parallel and they never intersect. But these two lines do intersect. So these are not skew. All right, those are not skew. So let's look at F and let's look at G. Let me highlight them. So here's F, and then back here is G. They definitely don't look parallel, so they're not parallel, but do they intersect? Well, it might look like they intersect by the way I highlighted it, but look at what's going on in the picture. This line F is going through at this point, but this line G is in the back. Pretend this is a sheet of paper. It's as if we have a sheet of paper, and I draw a line back here, but then I come through and I draw a line going through that way. Do you notice that this line and this line never touch? One's on the sheet of paper and this one's going through it. That's what's happening in this picture right here. So these don't intersect and they're not parallel, so yes, they are skewed lines. Okay? So what I would like you to do is I want you to try these examples. Just try them out. They don't have to be perfectly correct. I just want to see what you can do, and I want you to try those examples for class. Very similar to what we just talked about. Let's do this. Name a plane that appears parallel to plane B. Well, first, find plane B. Plane B is here. What plane looks like it's parallel to that plane? Well, if you look, it looks like plane C is parallel to that plane. Plane C, not plane B. That doesn't look parallel. So it says, name a line that appears perpendicular to plane B. So look at plane B. What line hits it at a 90-degree angle? Well, I see 90 degrees here, right? However, we got to figure out what line they're trying to talk about. Well, M is laying on the plane. So if it's on the plane, then it's definitely not perpendicular to the plane. So the line that's going through must be the one perpendicular to the plane. And that would be line L. All right? So now that we have that done, let's keep on going. Okay, on this part here, I want you to try this. So you try this one and bring this with you to class, and we'll go over it. So make sure you do try this one on your own, and then we'll discuss it in class, okay? In the diagram here, what does this mean? What does that mean? Perpendicular. So R is perpendicular to S, and they have that marked right here. And they tell you R is perpendicular to T, and they have that marked right here. Determine whether enough information is given to conclude that the statement is true. 3 is congruent to 5. Well, here's 3 and it has a 90-degree mark. And here's 5 and it has a 90-degree mark. So yes, they're congruent, right? That's a true statement. You're good to go. That's a yes. Let's look at the next one. They want to know if 4 is congruent to 5. Well, we're going to have to think a little bit here about things we've already learned in class. I know if this is 90 degrees right here, 4 is a vertical angle to angle 3. And if it's vertical, then it's the same measure. So angle 4 must also be 90 degrees. So now, is angle 4 and angle 5 congruent to each other? Yes, they are. So watch out for those vertical angles. Then let's look at angle 2 and let's look at angle 3. Now the problem with angle 2 is I know nothing about its vertical angle. Look, I don't know anything about its vertical angle. I don't know how much its supplementary angles are. So I literally can't find any information out about angle 2 right now. So I don't know anything about angle 2. And if I don't know anything about angle 2, I definitely don't know that it's equal to angle 3. So no. Need more info about angle 2. We definitely would need more information about angle 2. Now in this part here, I would like you to try and bring those to class. They're very similar to what I just did. So go ahead and give those a shot and bring those into class. Let's go down to this part. I'm actually going to work with you on number 9 because it's the most complicated, and then I think you can handle 7 and 8 on your own. So let's first look at 9. KJ is perpendicular to KL. And look, they did that already. They put the box in there for us. The next thing they say is JKM is equal to MKL. Well, look, they took care of that. They labeled both of them Z. They're both exactly the same. So now we have to solve and find the value of the variable. Well, looks like they are 90 degrees, correct? So angle Z plus the other angle, which is Z, should equal 90 degrees. Then we add these together and we get 2Z equals 90. And then what do we do to both sides? Divide. So we'll get Z is 45 degrees. And we've solved for the variable. I would like you to try 7 and 8. Okay? So finish up all those problems I asked you to try, bring those to class, and we will go over them then. If you have any questions, make sure that you send me an email and let me know, and I'll be happy to help you there too. And remember, I always recommend watching the video twice, and then you're really going to know what's going on. All right, finish those up. See you in class. Bye-bye.